All right, guys, so this is how we're going to do our notes today. This is section 2.7. So the last couple of days, we jumped back to chapter 1 to do 2 and 3-dimensional figures. And then today we're moving back into chapter 2 and looking at parallel lines and transversals. And you guys will see that the second part of chapter 2, we're moving away from logic and we're getting more back into our algebra stuff, our calculations, working with numbers more than we are with words. Okay, so if you guys will pause the video for just a second, I want you guys to work on the warm-up problems. This is what we did back in chapter 2. I want you to find the perimeter of a triangle. Mine kind of got cut off, but they should be the same points as yours. So to find the perimeter of a triangle, and you're going to have to use the distance formula since you were given 3 ordered pairs. And then I also want you to find the midpoint of the segment. Okay, so if you guys will just take a second and do that. All right, so if you've paused the video and worked everything out, for the first points, I labeled them A and B, so I'm going to find the distance between A and B. So you plug that into your square root. This would be 1 plus 6 squared plus 2 minus 2 squared. And for this distance, I got 7. We'll do the distance from B to C. I found the distance to be negative 6 plus 6 squared plus 2 minus 9 squared. And I also got 7 for that distance. And then the last distance we need to find is from A to C. See if I can squeeze it in here. So I got 1 plus 6 squared plus 2 minus 9 squared. And for that distance, I got 9.9. And then when you add all of those up to find your perimeter, you should get 23.9 units. Okay, so just kind of a recap. I guess I should have done this first, but the distance formula is x2 minus x1 squared plus y2 minus y1 squared. And again, it doesn't matter which x value you make x2 or x1, and the same with the y's, as long as you plug them in order based on the ordered pairs that you chose, you should get the correct answer. Okay, so this is distance. And then midpoint, I filled in my points for the midpoint. So midpoint, the formula is x1 plus x2 divided by 2, and y1 plus y2 divided by 2, because you're finding the halfway point between those. So our x values here are 2 and 10, and our y values here are 3 and 11, and we'll divide both those by 2. So 10 plus 2 is 12, divided by 2 is 6. 3 plus 11 is 14, divided by 2 is 7. So your ordered pair here should be 6, 7, and that is the midpoint. Okay, so that's your warm-up. Like I said, that's from chapter 1. Hopefully that looked familiar, all kind of coming back to you. Make sure you're remembering those things, because we will see this again and again throughout this course. All right, you guys will go down to the next slide. We're going to look at 2.7. So we're looking at parallel lines, and then we have these things called a transversal. And a transversal is something that just cuts through 2 parallel lines. So we'll see that in a little bit. Okay, parallel lines, we've defined this before. They are lines that are coplanar and do not intersect. Okay, so you can see here's 2 parallel lines that don't intersect, and this is the way that we would write them. If you see these 2 lines like this, that means that C is parallel to D. Okay, that might kind of look familiar. When we were doing perpendicular, we might have had something like this, an upside down T that represented perpendicular. So this is going to be our sign for parallel when we have parallel lines. Okay, skew, we've talked about skew before. Those are lines that are not coplanar and do not intersect. So if you notice, this line is just passing through this plane. It only intersects the plane at this one point, but it would never intersect or touch with this line in the plane. This one's just strictly passing through. This one lies in the plane. Okay, and then perpendicular lines, we know that those are lines that form right angles. And so like I showed you above, there's your little symbol for perpendicular. Okay, so intersecting lines that are perpendicular form 4 90-degree angles. So there's a 90 there, but that means all the other angles around are going to be 90. All right, flip over. Okay, so we're going to look at some of those words that we just used, parallel, perpendicular, and skew, and figure out which one fits the description looking at this cube, okay? So we want a line that is parallel to TW and contains point V, okay? So if we look right here, we've got TW, and we know that we need to find something that's in the same plane as that. It's going to be parallel. And so if we look here, this back here contains point V. So we would say that segment UV is parallel to TW. Okay. Looking at B, perpendicular to PS and contains point R. So we know that PS is right up here in this top plane, and we know that we need to find a line that's perpendicular to that. So if we know anything about a cube, we know that all of the lines that intersect are going to form 90-degree angles. That's just what we know about squares. And then if we make a square into a cube, it's the same concept. So PS and containing R, that would be this segment back here. That would form that 90-degree angle in that top corner of the plane. Okay, so we would say that SR is perpendicular to PS. All right, skew was sometimes the hardest one to figure out because we were looking for something in a different plane, not intersecting the line that we were given. So if we want to find a line that is, or a segment that is skewed to TW, which is this line right here, and it contains V. Okay, well, we can't use this line right here because those intersect, TW and VW intersect, and they're in the same plane, so we're not going to use that. The only segment that would work for that would be VR, because VR is on this edge back here, making up these back two planes, and TW is down here in this front plane. It would never intersect or touch VR. Okay, so we'll say that segment VR is skew. Okay, and then planes can be parallel to one another. So even though they're not going to be within the same plane, we know that if we have two planes and they are running vertically or horizontally, they're going to be parallel to each other. So a plane that contains point V and is parallel to plane TPQ. Okay, so plane TPQ is this face over here, this side. So TPQ, it includes U as well. So it's this plane on the side. And we're looking for a plane that's parallel to that one that contains V. So again, if we come over here to V, we notice that there's this side of the cube, and this plane right here is going to be parallel to this plane. And hopefully that makes sense because those are the two sides of the plane. And so they are the two sides of the cube. And so those would make up parallel planes. Okay, so we're going to say a plane that is parallel to TPQ is plane, we'll say SRV, and we'll go ahead and put the fourth letter in there just so we can classify the whole thing, SRVW. All right, slide on down. This is the meat of our lesson today. We're looking at our angles and looking at parallel lines, okay? So we're going to learn 4 to 5 different types of angles when we have two parallel lines that are being cut by a transversal, okay? So right here, even though these lines are not marked as parallel, we're going to view them as being parallel. And this is a transversal, okay? And so I labeled it T to help us remember it's transversal, but it's going to cut through two parallel lines, okay? And it's going to give us these different kind of angles. These transversals are going to create angles for us that we're about to learn, okay? So exterior angles, those are angles on the outside of the lines, okay? So here are our two lines that we're looking at. We've got this transversal here. The exterior angles are going to be here, 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 and here. Okay, so if we're thinking about railroad tracks, those are on the outside of the tracks, right? They're not within the tracks, okay? Our interior angles are going to be the angles on the inside. So these are interior angles. These 4 angles are within the tracks, okay? All right, let's keep going. A transversal, I just showed you guys, that is a line that intersects two or more coplanar lines at different points. So these two lines are coplanar, and this is a transversal that intersects those two lines. Okay? When we have corresponding angles, so when we have a transversal that cuts through lines, we're going to have corresponding angles, and those are angles that are going to occupy the same position on both of the lines, okay? So if I look here, if I make this angle 1, okay, the angle that corresponds with angle 1 is going to be this angle right in here, okay? So if I looked at just this line, this would be above the line to the left, okay, to the left of the transversal. So I'm going to do the same down here. I'm going to look above the line and to the left of the transversal, okay? And so these angles, 1 and 2, those would be corresponding angles because they're in the same position. Okay, so we'll say angle 1 and angle 2. Okay, we could do the same thing on the other side. If I'm looking above the line to the right, let's say I make that angle 3. When I move down to this line, above the line to the right, or sorry, let's not make that 3. We'll make this angle 4. So those are going to be corresponding. Okay, so those occupy the same position on the lines. This line to the right, this line to the right. So we'll say that angle 3 and angle 4 are corresponding. Now we could do the same thing for the angles that are underneath the lines. So let's say I make this angle 5. This is below the line to the left. I come down here below the line to the left. I'll make angle 6. So angle 5 and angle 6 are corresponding. And lastly, I'll do the same thing to the right. I'll make angle 7 and angle 8. And because those occupy the same position, those are going to be considered corresponding. Okay, if I look at alternate exterior angles, I know that exterior angles lie outside of the line. So again, if I'm looking at this like they are railroad tracks, the outside of the line is up here and down here, not in between the two lines, okay? So that's the exterior angles. The word alternate just means on opposite sides, okay? So alternate means that one's going to be on one side and the other is going to be on the other. Okay, so if I look at alternate exterior angles, let's say I put angle 1 here. So this is an exterior angle because it's not in between my tracks. So angle 1 will be out here. And because angle 1 is on the left side of my transversal, an alternate or an opposite exterior angle to angle 1 would be down here at angle 2. So they are on opposite sides of the transversal, okay? But they are going to be exterior angles and they are alternate because they're on opposite sides, okay? So angle 1 and angle 2 are alternate exterior angles. I could do the same thing on the other side. If I had an angle 3, it's on the exterior to the right, okay? But the alternate interior angle to angle 3 would have to be on the opposite side of the transversal on the exterior. So 3 and 4, those are going to be alternate exterior. Okay? On that same note, we have alternate interior angles. So those are going to be the angles that lie in between the two lines, so in between our railroad tracks, and they're also going to be on opposite sides of the transversal. So if I have angle, let's say I make this angle 5, it is to the left of the transversal. If I come down to this line over here, the alternate angle to number 5 would be 6 on the right side. So those are interior angles on opposite sides of the transversal. So 5 and 6 are alternate interior angles. And I could do the same thing on the other side. If I had angle 7 here, the alternate interior angle to angle 7 would be angle 8. They're on opposite sides of the transversal on the inside of your lines. Angle 7 and angle 8.